Am I audible? I'm visible. Okay, very well. So let's start with the kinematics part 2. So in kinematics part 2, we are mostly going to study motion of projectile. Suppose this is a horizontal ground and I'm shooting a ball with a velocity u at an angle theta. Now I'm interested in understanding this motion. This is the simplest form of 2D motion. The ball, as you see in everyday life, reaches some maximum height and it has some range. You can see this is a very symmetric curve. What this curve would look like? What do we call? This will be a parabola. We can quickly find out. Okay, we will do that. Now the gravity is acting downwards. What are the other things? We are interested to find the range. We are interested to find the maximum height. Okay, now I'm going to segregate this motion in 2D as x direction motion and as a y direction motion. Okay, in x direction, what is happening? I'm going to use the equations of kinematics. So we have the first equation. At any moment, what will be the Vx? Vx will be u cos theta. At any moment, what is the acceleration along x direction? Any answer? Quick, quick, quick.
0.
So 0.
0. Wonderful.
0.
Now I hear. Okay. So if I want to know how much Sx, distance in x direction, it travels, it will be S is Vx times time of flight. Right? Vx I am aware of. I forgot to tell one more thing. Everything in this direction I have taken positive. Okay, currently just right now I have this sign convention. So whenever you use kinematic equations, you need to be clear with the coordinate system or reference. Everything in this direction I'm going to take positive. Okay, the choice is arbitrary, but I will stick to it. So my displacement in x direction is u cos theta time of flight. Right, in y direction, what is happening? My velocity in y direction I can find, but first let me see what is my acceleration in y direction. It is equal to minus g. See, I took an arbitrary convention. Everything up is positive. So I have minus g. Now, using this, I can find the y component of the velocity is u sine theta. At any given time, it will be initial velocity plus ay into t. Right? Do you all agree with this? Ay we know. Now, we are first interested to find the range. What happens at the range? The displacement in y is 0. What is the displacement in y direction? Is uy time of flight plus half ay time of flight squared. Right? Now, I want this to be 0 because when it is at range, its displacement in y direction is 0. It can happen 2 times. So you can see when you do 0, one trivial solution is time of flight is 0, or actually the initial condition. Another solution is uy is u sine theta plus half ay is minus g, and time of flight we are interested in. One time of flight I have already taken out. So this has to go to 0. Right? If I factorize this, now from this I can get time of flight is 2u sine theta by g. Do you all agree with this? Now, if you plug it in here, you will get 2u square sine theta cos theta by g. Right? Now, we are doing first very easy example, but then I'm going to go to projectile motion on inclined plane. And then I'm going to use some simplicity. So these results are really important. Okay, our range has come up this, and what we can say, our range will be u square sine 2 theta by g. Now our range will be maximum when sine 2 theta is 1. When is sine 2 theta 1?
And theta pi by 4.
Exactly. Range is max when 2 theta is equal to pi by 2 or theta is equal to pi by 4. Now this is direct, but you can also differentiate and then equate the first derivative and then check with the second derivative if it is really the maximum. Okay, now let's go for the next point. That is the maximum height. H max, what do we do? What is the condition for H max? For H max, at the highest point, what is happening? Projectile only has the horizontal velocity. Here, it doesn't possess any Vy, right? If it possessed any Vy, it would be going further high. Do you all agree with this? So you can imagine I have these two pens to show what was the initial condition. I launched with some horizontal component, with some vertical component, and while on the journey, as it was going from here to this point, the vertical velocity was going smaller and smaller. At the highest point, the vertical velocity is 0, and then subsequently it would move down, right? And it will have a thing like this. So at the highest point, Vy is equal to 0. So if you do Vy, we know is here, u sine theta minus g t, I say th. Th is the time for maximum height at t is equal to th. Now I can find the time for the h max is th is u sine theta by g. Do you all agree with this? Any question, any doubt? Quick.
No, sir.
Okay, you see, this is really half of the time of flight. As I said before, this is a very symmetric motion. Okay, now with this, we can find Sy. Sy at th is actually the maximum height, right? The displacement in y direction at th will give me maximum height. And I know here is the displacement, right? This is the displacement. So I can write uy th plus half ay th square, right? And then I can write it down as u sine theta. You will get a square because th is u sine theta by g. Now here ay is minus, so I will take g minus by 2, and this will be u sine theta square by g square, right? So we found the range is this, and the maximum height is h max is u square sine square theta by 2g. Do you all agree with this? Quick. Okay. Now I'm interested in finding what is the trajectory of my projectile. how does it look like? What it is? Is it a circle? Is it a hyperbola? Is it a parabola? So we can denote the x coordinate at any moment as x is equal to u cos theta times the time. And we can represent the y displacement. So I'm taking any xy position, x and y, because if we can find out x and y, then we know what kind of curve it is. Now y is equal to u sine theta ut plus half ay t square. Ay is minus g by 2 t square. Right. So from this, you can get time as x by u cos theta. Right. And if you plug it in here, you would get the equation of the trajectory. Let's have a very quick look. It's just simple substitution. Y will become x times tan theta, because this will be sine divided by cos, u will be cancelled, and x will be there, minus g by 2, and then t square. So this will be x square by u square cos square theta. Right. So our equation of this curve will be given by this equation. Right. Does this equation seem familiar to you? Please don't be worried about equations. If you just know them, it's easy to recognize. It has a term x square, and it has something like this. Y is equal to function of x square. Now this is a parabola.
Parabola.
Right? Very well. So now we understand everything about the projectile motion. I did this case because this is the easiest one. Okay. Now we have to graduate to a little bit complicated case, right? And we will finish perhaps 5-10 minutes early. Any question, any doubt?
No, sir.
Any question? Please interrupt me whenever you have the doubt. No doubts? Everybody fine?
Yes, sir.
Let's do just one more example. Suppose I have an elevated post. You can imagine near any kind of fence, there is a guard place. And from there, they can shoot something, right? Suppose at a height h, I can throw a projectile at an angle theta. Now, can you please calculate what is the range? Okay. And what is the h max? Can you calculate what is the velocity when he's again at the projectile is again at the same height? And what angle does it make with respect to x-axis? Suppose it makes an angle alpha. So I need range h max alpha. Can you give a try? Quick. Can you please give a try? So how do we do? We write in x direction, we write the motion in y direction, and then suppose we want to find first h max. Okay, we know in x direction it is u cos theta is ux, uy is u sin theta, vx is u cos theta plus ax into t. Ax is equal to 0 because this is not a propelled RPG, or it is just something like a bullet. So it has already finished its propulsion when it was launched. So acceleration is always 0 for a projectile. Now in y direction we have g. So here we have ay is equal to minus g. I'm this time again taking this as my positive direction. I'm taking this as my positive direction. This is my x, this is my y. Okay, sign convention is very important because right now all the action is happening towards the ground. So what I'm going to do, I'm going to demonstrate this time if I take this direction as positive y. Okay, if I take that direction as positive y, my g is going to be plus. And I'm going to demonstrate the choice is arbitrary, but if you stick to your sign convention, you will always get the correct answer. So Vy is equal to u sine theta plus Ay into t. Right. Now what happens for the h max? At the h max, my Vy is going to 0. When my Vy is 0, I know the time is given by u sine theta upon Ay, which is again g. Right? So this is my time to reach the maximum height. Now, if I plug it in here, or how can I calculate the maximum height? I can use the third equation of motion. I could do second equation of motion, Sy, right? Now, according to my coordinate system, this is my origin. Okay, so I have to add an extra height h. Currently, I will get Sy with respect to my origin, which says that this is the 0. But if I have to report h max with respect to ground, then I have to add in Sy also h. So to find, so this is actually my h max. My Sy at th is the time when its y velocity became 0. Okay, th. Now my sth can be easily obtained by uy th plus half ay th square. Okay, one approach is this. Another approach is direct. We know Vy square, right, at th is equal to uy square at t equal to th plus 2ay into sy, right? I know this is 0 at the maximum point. So from this, I can get in one shot. To get the h max, first I have to calculate th, time to reach the maximum height, and then through this equation, I can find this height and then add for h max. Otherwise, I can find this sy th directly, right? Because this sy th is the time when it is at the maximum point, will be minus uy square, right? And now minus uy square by 2ay. Now you can see my sy is this distance. Okay, so I really have to do like this. My Sy will be negative, which is clear. So it will be u square sine square theta by 2g, and there is a minus. Okay. Please don't get confused. Is everything fine?
Yes, sir.
Okay. Now I have this displacement. So my h max will be some h plus u square sine square theta by 2g. Okay. So you got h max. Now, can you calculate the range? Please open your notebook. What will happen at range? Now, you see, if you remember the formula from our last derivation, for range, it won't work. Range is no more r is equal to 2u sine theta cos theta by g, right? It's no more true. Why? Because the condition for the range is when my particle is at the range, my Sy is equal to plus h, right? My Sy is equal to plus h. So what can I do to find the range? I need to find time of flight. If I know Sy, I can write Sy is uy time of flight plus ay time of flight squared, right? Any answer? Do you all agree with this?
Yes, sir.
So this is just one equation and there is one variable. This is quadratic equation. You will get two roots. It will be a quadratic equation. See, this will give you h, my displacement when it reached at the range. H is equal to uy, u sine theta, time of flight, plus, now everything down is positive, so my g is also positive, g, time of flight, square by 2. So I can get time of flight from this. Okay, let me try. But you have to do this problem one time in your life, in your notebook, all alone, with beautiful writing, then you will never forget. Okay. So I'm going to rewrite this equation, Tf square is equal to, okay, plus, if I multiply this equation with 2 and divide by g, entire equation, what will happen? 2u sine theta by g into Tf and minus gh, sorry, 2h upon g. This is equal to 0. So this is the equation I will get. And now this is straightforward. You can write time of flight is minus b, so minus 2u sine theta minus b plus minus square root, and then everything divided by 2a. A is just 1, 2a. So b square and then minus minus plus 4 to the 8, 4ac. Okay, now you can clearly see the time has to be positive, right? So the negative root will go away. All right, the negative root will go away. And so your time of flight is this. Now you just have to multiply this term with u cos theta. So range will be u cos theta, entire thing times u cos theta. Right? Is this clear? So you never have to remember things if you can solve with the set of logic. At range, I would know what is my y position. According to my coordinate system, it is h below. Now, this is another interesting question. Perhaps you can investigate yourself. What is the velocity here? What is the alpha? Okay, I can just tell you the answer is alpha is going to be theta, because this is symmetric motion. So just prove that alpha is equal to theta. If you just take the ratio of the velocities, you will get theta. Any question, any doubt?
No, sir.
In 5 minutes, I'm going to do a very horrible problem in very easy manner, okay? And then our class will be open. Any question, any doubt?
No, sir.
No.
Okay. Okay, very well. I think we will manage with this board. Suppose now I'm interested in projectile motion over an inclined plane. Suppose this plane is inclined by an angle alpha, right? Now I have a projectile and I throw it in exact same manner as before. In Kargil war, they were fighting with the terrorists at the mountain. So they use howitzers, which is inclined at an angle theta. So this is a Swiss gun which shoots at an angle theta, and it goes and lands to this position. Now this is the point where we want to shoot. So this is called range. Again, I'm interested in range. Now how to solve this problem? My G is downward. Any suggestion?
So can we change the reference and make the x along the plane?
So if we take
Very well,
x
very
as
good idea.
the incline as x coordinate, then g can be cos alpha g.
Exactly, very good observation. So if we get a horrible problem, a lot of time we have to relate and make it similar to the easier problem. So in problem solving, either you make the problem easy and then increase the complexity, or you rephrase this problem and bring it into a familiar or nice form, right? So we can take this direction as plus x direction and this direction perpendicular to this wedge as y positive direction, right? Now in this s cubed, okay, so you have to just twist a bit. You will have again the x direction and the y direction, right? And then our life will become easy, as because our motion is symmetric and everything is fine, right? But before reaching there is a slight change in the problem. You see, the gravity was down in the easiest case when our plane was flat, right? Now our plane has become inclined. See my angle twist? This has got at an angle alpha, right? So I have to make some changes in acceleration. So you can see my acceleration due to gravity is down, but I will take a component that is perpendicular to the plane. So this will be my gy, okay?
Yeah.
And this will be my gx. You got the point? Now this angle will be alpha. Just we have to be very careful. Just like money accounting, here is angle accounting, right? So our ax is this gx, and you see the gx is in this direction. Our positive x direction was here, right? So our ax is minus g
Sine.
sine alpha, and our ay is minus g cos alpha.
Alpha.
Very well. Does everybody gets this point? Now this is the only difference. Now our projectile has acceleration both in x and both in y direction. So as soon as you ask a question, you can switch off your mics. Sometimes the background noise can be there, but don't hesitate to open your mic. You can open the mic, ask me a question, then close. Okay, thanks a lot. Now my world will be same. My Vx will be u cos theta plus ax into t, the first equation of kinematics. My Sx, displacement in x direction, will be ux ut plus half ax into t, right?
Square.
And so on, right? Similarly, it will be Vy is equal to u sine theta, u sine theta plus ay into t, and sy will be uyt plus half ay into t square. So still everything is for these three equations. Just a little bit more accounting. Now I'm interested in range. What happens at range? At my range, sy is going to be 0. Right, so I'm going to put here my uy is u sine theta into time of flight. I would say at range I have the time that is called time of flight minus g cos alpha, that is my a, by 2 tf square. Right, so from this I can find time of flight. Time of flight, if I solve this equation, is equal to 0. Now this time of flight cannot be 0, otherwise it will be trivial solution. So time of flight has to be 2u sine theta by g cos alpha. You see, very beautiful expression. And you see, this is different, right? If I had memorized and I have not paid attention, I would have done mistake. But I could memorize smartly. I remember in the symmetric problem, 2u sine theta by acceleration in y direction. You can see this is the gy. So you can remember smartly, or you can remember the logic. Now, if you have this time, my range is just u cos theta, and I have to plug in this time of flight plus half ax time of flight. I think you all will be able to do. I think our time is up. Any question, any doubt? Quick.
Okay, sir.
Okay, now this is easy. Very well. So any questions, any doubt? So in the next class, I'm going to bring a lot of problems related to topics we discussed.
Okay, sir.
Thanks a lot for your attention.
Thank you, sir.
Have a great day.
Thank you, sir.
Thanks a lot. Any question? Any burning question? Once Sakshi, Pratham, Shriya. Okay. Survey.
So what is the answer?
Okay, just let's fill in the blank if you have time. The range will be u cos theta, and then we have 2u sine theta. It will be very systematic and good looking expression, plus half. Now ax is again minus g sine alpha into time of flight, 2u, this is square, sorry, ut plus half at square, 2u sine theta by g cos alpha to the power. Do you agree with this? So our range will be 2u square. Let's take out 2u square by g. We can take out. Definitely we can take cos alpha. Right? It's here and it's there. And what do we have? We can take even sine theta out. We can take the sine theta out. Right? 2u and even
Yes.
u square. Okay. Wonderful. Now this 2 goes away.
So, but
1g
we
up
took that
goes away.
common. We can't cancel.
2u square by g cos alpha. So here there is only cos theta.
Cos theta
And
minus
then
g
we have
sine.
minus, this g is gone because here was g square, and we have sine alpha. So we have sine alpha by cos alpha, and one sine theta is out, so one sine theta.
Yeah.
Right?
Yes.
Now this expression looks really very beautiful, right? 2u square sine theta by g cos square alpha, and you have cos theta cos alpha minus sine theta sine alpha. What will be the answer?
Sine 2 theta. No. Cos 2 theta.
Cos theta plus alpha.
Right. Oh, okay.
Right, so this looks a good expression if I'm
Yes.
correct.
And it's similar to the range in not inclined project.
Yeah, it is different. So
Yeah.
if you memorize formulae, the things may not work. So
Yes.
I never remember. I use logic and very high speed, 30 seconds you can get this.
Yes.
Okay, thanks a lot.
Thank you, sir.
I see you tomorrow. I mean the next class.
Yeah. Yes.